Now we come towards the chain reaction. As I have explained earlier, that chain reaction is started by 2 neutrons out of 3, and the chain reaction neutrons have energy nearly 1.2 MeV, and the third neutron, called thermal neutron, has an energy of 1 million electron volt. So chain reaction is started by 2 neutrons. 2 neutrons give rise to 4, 4 give rise to 8, 8 give rise to 16, and so on, and this variation goes on in geometric sequence. When uranium is bombarded by neutrons, each uranium nucleus is broken into 2 nearly equal fragments. When we use the term fragments, we are referring to barium and krypton. Their tendency is to generate the visible radiations. So how to recognize the visible radiations? By just checking their frequency and wavelength. For the fragments which are emitting the visible radiations have frequency of 10 to the power 15 Hertz or wavelength of 10 to the power minus 7 meters. Along with huge energy or 2 or more, average 2.5 neutrons are liberated. 3 neutrons fission other uranium nuclei in the same way. Thus, a chain of the nuclear fission is established, which continues until the whole of uranium is consumed. There are following main difficulties in establishing a chain reaction. So in the chain reaction, leaking or escaping of neutrons from the system is possible. Absorption of neutrons by unbroken nuclei present in the system. And another thing is absorption of neutrons by uranium-238. These are some important difficulties which are difficult to overcome. Then critical mass is very necessary. We find that critical mass of uranium is nearly 10 kilograms for starting fission. So minimum mass of uranium system or any other system for which chain reaction is possible is called critical mass. It is 10 kilograms for uranium-235. The necessary condition for the nuclear fission is that there must be at least one neutron which takes part in nuclear fission. Normally, this condition is known as multiplication factor or reproduction factor. So, if the reproduction factor is less than 1, then we find that the chain reaction will finally stop. And if k is greater than or equal to 1, the chain reaction will continue. And this can be spoken in other words also. That is, if up to the time the ratio of the chain reaction neutron to thermal neutron will remain 2:1, the chain reaction will continue. Number of neutrons emitted during fission reaction depend upon the volume of system. When we use the system, we are referring to 92 uranium-235, so its volume is very important. However, the heavy nuclei are highly compressed. But the number of neutron emission depends upon directly on the R cube, where R is the radius of the nucleus. As I have explained earlier, the order of the nuclear radius is about 10 to the power minus 15. So obviously the order of volume is 10 to the power minus 45 meter cube. The rate of leaking of neutrons from the system is directly proportional to the area of system. Now, area of the system means area of 92 uranium-235. As I have explained earlier, that is order of radius is 10 to the power minus 15, and the order of area of the nucleus will be, from formula 4 pi r square, will be 10 to the power minus 30 meters square. And that is, and this number we can represent in bar. One bar is supposed to be 10 to the power minus 28 meter square. Now, different types of chain reactions are there. One is called a controlled chain reaction and other is called uncontrolled chain reaction. Well, uncontrolled chain reaction, when we speak, we are referring to for the destructive purpose in the form of atomic bomb. And when we speak the constructive, that is the chain reaction controlled, we are achieving it under certain specific condition in a nuclear reactor, and that controlled chain reaction is responsible for the generation of electrical energy, which is useful for the production of electrical power. So chain reactions are specified as controlled and uncontrolled. Controlled chain reaction, I have already given the description. The rate of reproduction in controlled reaction is equal to 1. That is, we are referring to the value of K. K will be 1. So that is one of the criteria for a controlled chain reaction. Energy liberated in this type of reaction is always less than explosive energy, and it proceeds with a certain velocity. This type of energy is used in constructive work. The constructive work is the production of electrical energy with the help of controlled chain reaction. So there are different type of reactors which are producing this constructive work. That is, we are getting certain megawatts of the electricity. Nuclear reactor uses this principle exactly. That is, nuclear reactor. We have to refer nuclear reactor which has three parts. One is called the fuel unit, other is the moderator, and the third component is control rod. Well, control rods are made up of cadmium or boron, and their purpose is to absorb the neutrons which are not required in the nuclear reaction. Then second part is called the moderator, where we slow down the neutrons obtained from a source of neutron. That is, there is a source of neutron, we get neutrons from that source and we pass through the moderator, which is made up of heavy water. So when it is passed through moderator, its speed slows down and its energy becomes 1 to 1.2 MeV, and then this neutron is projected in the fuel unit on the fissionable material like 92 uranium-235, and the fission reaction starts. So in the main context we come, that is, the nuclear reactor is a device in which self-sustaining controlled chain reaction is established to produce energy, which is used for any useful purpose. In this reactor, at least one neutron liberated in a step can fission next nucleus, and it is controlled artificially. A modern reactor has following important parts, which I have already described. That is, number one is a fission substance. So we will not more elaborately say it as a fuel, but fissionable substance is recovered from fuel. It is a substance used for fission, natural fission, or natural uranium-235, that is enriched uranium, are used for this purpose. Other fuels are 94 plutonium-239. We can say it is rather more fissionable, and uranium-233. Quantity of fissionable materials should be equal to the critical mass, that is 10 kilograms, and plutonium-239 and uranium-233 are synthetic fissionable materials. The second part of the reactor is called the moderator. As I have explained earlier, it will slow down the fast neutron, which is obtained from the source of neutrons, which is normally beryllium. So it is used to slow down the fast neutrons and changes to thermal neutron. Heavy water, graphite, or beryllium oxide is used for this purpose. Heavy water is the best moderator. So the main purpose of moderator is to slow down the neutron so that it acquires the energy of 1 to 1.2 MeV to start the fission. Neutron source, it is used to start the chain reaction. Now we come towards the controller. That is, the control rods are in the form of cadmium or boron. However, cadmium is a very good absorber of neutron. So cadmium rods are used to control the rate of fission reaction. Cadmium is very good absorber of neutrons. Now next part is coolant. That is, after some time the reactor becomes hot. To cool it, we use the coolant. The energy released inside the reactor in the form of heat is controlled by coolant. For this purpose, we use air, ice, cold water, or carbon dioxide is flown in the reactor. Then there is called a shielding. During the nuclear fission process, some very harmful radiations are given out. In order to control them, we find that reactor is covered by very thick walls, and they are made up of generally lead. And otherwise, that is 7 to 8 feet thick concrete walls, or lead also absorbs the harmful radiations. Then we come towards the uses of nuclear fission. Obviously, as I have explained, it can be used for destructive process as well as for constructive process. In the constructive process, it is used for getting electrical power. So, number one is energy production. Number two is in the manufacturing of radioisotopes, which are used in agriculture, medical, industry, biological, and scientific discoveries. There are certain important isotopes like 11 sodium 24. It is injected in the right ventricle, and you'll find that it is used in the medical sciences. Similarly, we find that silicon, it is used in industry. Then there are certain uses of the fission in the manufacturing of plutonium-239, and this is used in atomic bomb. This is synthetic fissionable element. Uncontrolled chain reaction, that is for the destructive purpose in the form of atom bomb. There is no control over this type of nuclear reaction. In this type of reaction, more than one neutron takes part in reaction, and due to this, the nuclear fission increases. Well, the uncontrolled chain reaction can be carried out. That is, like one of them is called implosion device, and this is done underground. That is, we drill the earth for certain meters to a certain depth, and there we keep the atomic device, and then we test the atomic device about its strength. Then another is called the explosion technique, that is carried out in sea. For this type of reaction, the reproduction factor K is greater than 1 to sustain the chain reaction. A huge amount of energy is liberated in this type of reaction. Atom bomb is an example of the uncontrolled chain reaction.